Hello students, welcome back to my you can say your YouTube channel. So as earlier we have discussed that is the importance of physics and how physics and all physical phenomena and some of the physical phenomena which we have discussed, and what are the forces in our nature. So like physics is a study of nature, and we have discussed all those stuff. So in our next chapter we will discuss units and measurements, and here in this video, if we discuss all this, then it will be a quite large video, so we will make the parts. First we will discuss the fundamental units, then what are the derived units, means from these fundamental units we derive all the units, all the other units discussed or will be used in our physics. After that, what is the role of significant figures and what are the rules of significant figures, and we will discuss some of the examples to understand or to make it clear. And this part we will discuss it in our next lecture. So starting fundamental units. So we have length as a fundamental unit which we used in every aspect, because from length we will find velocity, speed, acceleration, distance, displacement, and many more quantities. Work done will also be from length. So these are the derived units from length. Mass, this is also the fundamental unit which we required. Like in starting of our you can say childhood, what we know, what we take in our hand is having some mass. It is having some length in meter or in centimeter. So these are the fundamental units. Time, which never waits for anyone. So time is also a fundamental unit, because we are not able to derive time from any other units. So time is our fundamental unit. Here electric current, having symbol I, and the SI unit ampere. Here second, the SI unit of mass is kg. SI unit of length is meter. These are the SI units. Electric current, you will get to know about electric current in your 12th standard, but basically electric current is what the rate of change of charge, or more specifically time rate, because there is distance change also happens in gradients. So time rate means dq by dt. Okay, this is the electric current. Q is charge and with respect to time. Okay, moving further, in thermodynamics, temperature is also our fundamental unit. How temperature is fundamental unit? We always say that आज तो गर्मी बहुत ज़्यादा है. So heat, the form is in the form of, we measure the temperature, but here its SI unit is Kelvin, but mostly in our country we use degree centigrade or sometimes degree Fahrenheit. But in terms of physics, every phenomena, because it's in Boltzmann, for Bose-Einstein condensate form, we require very very less temperature, or we know, if you do not know, that there is like 0 Kelvin that can exist. Kelvin can never be in negative. So the fundamental unit is Kelvin, because it's always positive. We know 1 degree centigrade is equals to 273 Kelvin. For minus 273 degrees centigrade, which can be achieved like 272 degrees centigrade can be achieved using lasers, and there are if you studied in your 9th standard that resonance. Due to resonance, we can increase the frequency, or we can increase the amplitude of anything, or we can also decrease it. So if we decrease the motion, vibrational motion of our atoms, then we can freeze them, because in freezing what happens? The vibrational motion of the atoms decreases, and from external lasers implemented, if we freeze those if we freeze those atoms motion, then temperature certainly decreases. So here it is equals to 0 Kelvin. Got it? Amount of substance in chemistry you will study in your 11th standard mole. What is mole and everything. So amount of any substance will be in mole when solvent and solutes are involved. Luminous intensity. Intensity, you can say, if you in general, if you said that this battery or the light battery is more intense than this one, or from phone perspective, the intensity of this screen is higher than this. So what it means is that the light per unit area, per unit time is higher, then intensity will be higher. So light energy, here we energy per unit area per unit time means, like we have some area, two area, let's discuss, and here we have torch, and some energy falls on it in this form. These rays represents the energy, and there is some another torch, some big torch, where the energy is like a lot higher, and this area is same, time is same. So energy of second torch will be greater than energy of first torch. So intensity of second torch on this area will be higher than first torch in this area. So this is the fundamental unit. Moving further to our derived units. So kilometer, and these are the kilometer is from length, so it will not be here. Minutes, it will be here, because minutes is like we discussed here. This is our second. From second we derived minutes. So minutes means 1 minute 60 seconds. 1 minute is derived from second, which is a fundamental unit of time. Hour. 1 hour equals to 60 minutes. 1 minute equal to 60 seconds. So 1 hour contains 3600 seconds. 1 day. 1 day means 24 hours. 1 hour means 60 minutes. 60 minutes means 60 seconds. These number of seconds will be there in 1 day. For 1 year, 1 year contains 365 days, or in leap year it contains 366. So in 1 year there are 365 we consider. 1 day contains 24 hours. 1 hour contains 60 minutes, and 1 minute contains 60 seconds. This is the magnitude of seconds in our year. Degree. Degree is like how much angle was made. Liter. Liter is measured in ml, and this can also be measured in terms of length because not in length, in terms of mass, because there is ml and we take ml considerably equals to mg. So ton is a unit of mass, 1000 kg, 100 kg, area meter cube, volume meter square, meter cube, speed, which you will get the idea in your next chapter. Speed is meter per second, or distance traveled in time. Acceleration is velocity upon time. Wave number. If you know that this is our wave, starting from it, single wave, it will be our wavelength, the length of our whole wave. Sometimes it is measured from crust to crust, so it is like from this to this. This is our wavelength, same, because this part and this part was neglected. This is the amplitude of our wave. Frequency is per second, how this wave is traveling. So wave number is 2 pi by lambda. This is our wave number. Density, mass per unit volume, this is volume density, mass per unit area density, mass per unit length, linear density. Current, as I told you, current density is current per unit area, means this is ampere per meter square. This is the unit of this current density. For momentum is mass into velocity. Moment of inertia, frequency, all these we will discuss when we move further. Force is mass into acceleration. Pressure, force per unit area, same. Stress, force per unit area. Energy, work done is a form of energy, so you can derive from there, or kinetic energy you can learn from it, mgh, potential energy, and force into displacement, work, all these having units in joule. Okay. Power, work done per unit time. Power is same as radiant flux. Electric charge we can derive from current is equals to charge upon time, so charge will be current into time. Electric resistance is derived from our Ohm's law, V by I. Capacitance is equals to Q by V. Torque, you have heard that higher torque means higher rotations, more rotations. Like we in our while purchasing car, some dealer told you that the torque produced by this car is this, and it is pretty much higher than all these things, and it will take less time to reach 100 km per hour. So this is due to the torque. So higher torque means higher rotational energy or higher rotations. So torque. Surface tension, work done per unit length. Angular momentum, Boltzmann constant is required in your thermodynamics. Pressure gradient means change with respect to distance, and it can be any change. So pressure gradient, pressure change with distance. Impulse means, like sometimes you heard that you are much more impulsive, or you think for someone that she or he is very much impulsive. So impulsive means higher energy for small duration. When someone is impulsive means what it means? It means that they burst out very um, easily and on a short scale, very high energy state to ground state. They will reach to ground state. So impulse in our physics means force for a very short time, force into time. This is impulse. These are all derived units. Moving to the significant figures. So many of you think that what is the role of significant figure? There is always a question of the significant figure in our exam, in our IIT or in our NEET exam. So what is the role of this significant figure? Why are these important? Because in our experiments of nuclear physics, there is a role, or a nuclear size is 10 to the power minus 15 meter. So something happens to this nucleus, we require how much significance will be there from the obtained value from our experiment. So what is the significance of those values? So we will get those significance from significant figures. So these significant figures will be required when you are performing some experiment. So significant figure have some rules, that what are all the rules, that how we state that this is a significant figure, 5-digit significant figure, 4-digit significant figure. Okay. So first rule states that all non-zero digits are significant. Non-zero from 1 to 9. Like if we have 133, then there are 3 significant figures. Okay. 12, 2 significant figures. 1, 1, 1, 1, 4 significant figures. All zeros between 2 non-zeros are significant. It means that if we are having 1, 0, 2, then this will be counted as significant figure. So we have 3 significant figures. 1005, we have 4 significant figures. This rule states this. Moving to next rule, if number is less than 1, then all zeros to the left of non-zero digits are not significant. So what it means that less than 0 means in the decimal form. So in decimal form, if you are having 0.0005, this rule states that all zeros to the left are not significant. These are of no relevance. So we are having 1 significant digit here. But if we have 1 here, then all these will be counted, because this is non-zero, this is non-zero, and all zeros between non-zero will be significant. So for this, what we have 1, 2, 3, 4, 5 significant figures. Okay. Zeros to the right of the number with decimal are not significant. Without decimal are not significant. So what this rule states is that if we write our, like here I have given some example, 1 to 4 and 0, 0, 0. So these 3 are not counted as significant figure. So there are 3 significant figures here. Next, the zeros at the right side of the number with decimal are significant. As for non-decimal, these zeros to the right are not counted. But in case of decimal, these zeros to the right will be counted. So we have 5 significant figures. Got it? So let's revise. All non-zeros are significant. Zeros between 2 non-zeros will be significant. This can be written as 1, 2, 3, and this is 1, 0, 0, 5. Okay. If less than 0, then if it is, then these are non-significant. So number of significant figures will be 1, here 4, these are 3. 0 to the right side of a number without decimals are non-significant. So in this example, what we have, these are not significant. So we in total have 3 significant figures. Zeros to the right side of decimal places will be countable, 5 significant figures. So let's discuss some of the examples of these significant figures, and you can perform all these examples and you can practice, and you can pause this video and practice this and then continue. I will discuss it and continue the video after completing the exercise. Okay, so I am solving all these. All non-zeros will be countable, 3 significant figures. All zeros between non-zeros will be counted. So here what we have, 1, 2, 3, 4, 5 significant figures. All non-zeros will be counted, but zeros without decimal and on the right side will not be counted, 2 significant figures. Left side will not be counted, 1 significant figure. These zeros will be counted because these are between 2 non-zeros, and right side zeros after the decimal will be counted. So 1, 2, 3, 4, 5, 6 significant figures. All non-zeros, 4 significant figures. Here, tell me this. If we have 1.02 into 10 to the power 5, what we get? 10200. Got it? So this 10 to the power 5 do not have any role because currently we have 3 significant figures. Zeros between 2 non-zero will be countable, 3 significant figures, and here zeros after non-zero terms without decimal will not be counted. These are of no significance. So again we have 3 significant figures. So if anything will be in power, it will not contribute to any role if it is positive. If it is negative, then it will create decimals, and then also there is no role because 0.00000 left side figures of any number will not be counted in case of decimals. So in this example we have 3 significant figures. Here 2.3 and this 0 is in between 2 non-zero terms, so it will be counted, 4 significant figures. Left side zeros will not be counted, so 1, 2, 3, 4 significant figures. In between will be counted, 4 significant figures, and right side will not be counted, 4 significant figures. So in all these examples, what you can see is that 2308 is the base term. 2308, this is the base term. If we multiply it by 10 to the power minus 2, you will get a decimal here. Then also you are having 4 significant figures. If you multiply it with 10 to the power 1, 2308, 0, this will not be counted as significant figure, so you have 4 significant figure, again the same. So you can say that the power of this exponential term or 10 to the power anything will not be considered as a significant figure. Like in this case there is 78 power, so you are not going to write 78 zeros after something in your exam, so you can directly say there are 3 significant figures. Okay, here in this case 1 to 3, I have considered this example. So 1 to 3 is having 3 significant figures. 1 2 3 0 0. This is derived from 1 2 3 into 10 to the power 2. So we have 3 significant figures here. This is derived from 1 2 3 into 10 to the power 3. Not considered as significant figure. So 3 significant figure again. I think you will understand what are significant figures, and you can do any example. So I will give you some homework. Find the significant figures of 0.1050. How many significant figures will be there? And 57.002 into 10 to the power 1001. Do these two examples by yourself, and the answer will be, I will give the heart to the person which gives the right answer to these two in the comment section. So do comment and tell me what is the significant figure, so that I will get the idea that you understand all these things. Okay, so today let's do all up to this part. In the next time we will discuss about quadratic equation. You know how to find the roots. We will discuss how to find the roots. Quadratic equation is of the order 2. Ax square plus bx plus c equals to 0. This is a general form. The equation of circle, the equation of sphere, second order. Trigonometric function and their basic identities, we will discuss it. Pythagoras theorem, we will discuss it. Trigonometric and its identities will be discussed. And what are vectors and what is vector product, A cross B. What it means, we will discuss. And also, we will get, after all this, if we have time, then we will discuss about the topic which is also an important topic, errors. How they are transmitted in addition, subtraction, multiplication, exponential forms, how these are transferred. So thank you, and if you have any question, query or doubt, you may ask in the comment section. I will try to promptly reply to your questions. So thank you very much, and if there is some error in noise or in anything, kindly tell me. I will correct in the next lecture. So thank you.